morning, good evening, and good afternoon. Today, I am Shrijit Patel and my team, including Aryan Kali, Kshitish Deshmukh, Atharva Kamde, Siddhant Shinde, Shivam Kuratkar, and Abhidya, we are going to present our PPT on the topic Steps Involvement 3D Printing. So, 3D printing, which is also called as additive manufacturing, is the process of making 3D object from a digital file. In this process, the part is manufactured, laying down the successive layer until the object is created completely. It is nothing but the opposite of conventional subtractive manufacturing process in which cutting out or hollowing out of the material with from an instance milling machine. So this whole process of 3D printing include six major steps, which is 3D CAD model, converting to STL file, slicing, post process, slicing, then G code generation, then layer manufacturing, then post processing. So the first step is CAD model. In the first process, we actually craft a 3D digital model of the object that we want to create. CAD in CAD model, CAD stands for computer aided design, and we make this possible using CAD software. Some of the CAD software are SolidWorks, Fusion 360, Tinkercad, and for biomedical field, we can use Mimix and Magic X. Some there is also alternative of 3D CAD model software, which is 3D scanners, in which we lay down a base layer of we can say a default color, or you can say a non-reflecting color. We make some geometric points over the surface that we want to 3D scan, and then using a 3D scanner, we scan the whole area which we want to then convert into 3D digital file. It is way more easier conventional as compared to CAD model software, where we have to physically uh, trace down every detail of the object, but also it's bit more complex and expensive. Now, shifting to the next step, which is converting to STL file.
So the second step of 3D printing is converting the 3D CAD model into the STL file format. Once the digital model is completed, it is converted into an STL file. It is a file format that is essential for all 3D printing processes. STL is also known as Standard Tessellation Language or stereolithography, which is used for representing the surface geometry of 3D object. The STL file format represents a scenario of 3D model using triangular faces where each triangle represented by vertices, normal and vector which indicate outward facing direction of triangle.
Sliding. So the third step consists of sliding. In 3D printing, slicing is a critical step where STL file is divided into fine horizontal layers. Slicing software such as Thura, S-Slice 3R, and converts these slices into G-code file, which act as the set of instructions for the printer. Each slice represents a 2D cross section of the model, allowing the printer to construct the object layer by layer with precision.
Our next step is G-code generation. Slicing software generates G-code file which contain instruction for 3D printers, including path of print head, temperature setting, print speed, and layer height. The software allows to add support structure for hanging 3D objects.
So the next step in the 3D printing process after G-code generation is layered manufacturing. This step is further divided into two steps. First, setting up the printer. This involves loading the appropriate material for printing, preparing the print bed, and configuring the print settings. The second step is layered manufacturing. This step involves the actual printing by following the G-code instructions. Building the object layer by layer from the bottom is the crucial part.
So, myself Shivam Kuradkar. When a print finishes, it's not ready to use immediately. We need post processing to clean it up, improve its look, and make it stronger. Here are some main steps. Removing the print. We carefully detach the printed object from the build plate using the scraper, making sure we don't damage it. Then, removing supports. Support structure, if any are clipped or peeled off, This helps the model to take its proper shape. Then cleaning the surface. Leftover material and the rough edges are cleaned, sometimes by brushing, rinsing, and even alcohol baths. Then sanding and smoothing. We need model starting with rough sandpaper and moving the final grits to make the surface smooth. Some materials even allow chemical smoothing for an extra polishing look. Next is filling and painting. If there are gaps or defects, so we fill them with putty, and then model can be primed or painted, not just for looks but also for protection. Sometimes a clear coat or a sealant is added to the protect the paint and make sure it is more durable. In short, post processing is all short transforming of raw print into the final finish that looks great, perform well.
Final product. Our final product is ready. Apart from fuse deposit, there are other methods as well based on material like liquid based, which has stereolithography, digital light processing, and selective laser sintering, which uses liquid and semi-liquid based resins to manufacture the product. Another is solid based 3D printing, which has fuse deposition, direct energy deposition, and electron beam melting, which uses filament and metal powder to manufacture the product. 3D printing carries many advantages like rapid prototyping, customization, and personalization, but also faces some limitations like material limitations, time, and speed and post processing requirements.